Dear students, so we already discussed about three tests: nth term test, comparison test, and limit comparison test. So, by using these three tests, determine the convergence of square root of 1 by 4 plus root 2 by 6 plus root 3 by 8 plus etc. So what is the nth term here? Here what is xn? So xn equals square root of n by 2 n plus 2 or 2 into n plus 1. Okay, when n is 1, it is 1 by 4. When n is 2, it is the term inside the square root is 2 by 6 and so on. So xn equals square root of n by 2 into n plus 1. So what is limit xn? Therefore, limit xn equals, when n tends to infinity, limit xn equals square root of n into limit of n square root of n by 2 into n plus 1. That can be rearranged as n by 2n into 1 plus 1 by n. Okay. So when n tends to infinity, n and n cancelling each other. So it is 1 by root 2. It is strictly differs from 0. Okay. So limit xn equals 1 by root 2 differs from 0 means that is limit xn differs from 0. So by nth term test, sigma xn diverges. Okay. What is nth term test? Sigma xn converges, then limit xn equals 0. So its contrapositive argument is, if limit xn differs from 0, then sigma xn diverges. Clear? So, can you give an example of a convergent series sigma xn? So sigma xn converges and sigma yn diverges such that sigma xn plus yn converges. Can you give an example of such a series? Sigma xn convergent, sigma yn diverges, and then such that sigma xn plus yn convergent. Can you give any such or can exist if there exists any such a series? Actually, you cannot be find out such a series. Why? If possible, sigma xn converges. If possible, sigma xn converges and sigma yn diverges with sigma xn plus yn converges. Sigma xn converges means sigma minus xn also converges. Sure? Sigma xn converges, so sigma minus xn also converges. What is sigma xn plus yn? Such that sigma xn plus yn converges means, so sigma xn plus yn also converges. The sum of two convergent series is always converges. That means sigma xn plus yn plus minus xn. Sigma xn plus yn minus xn is also converges. That means sigma yn converges. So that's a contradiction to the choice of yn. How to choose this yn? Yn diverges. Sigma yn diverges. So you cannot be find out such a series in such a way that one of them is convergent and the other is diverges with their sum is convergent. Okay, it is impossible. Agreed? Okay. Then what about the series sigma n ranges from 1 to infinity cos n? Is it diverge or converges? Sigma n ranges from 1 to infinity. Sigma n ranges from 1 to infinity cos n. Is it diverge or converges? So, if sigma n ranges from 1 to infinity cos n is converges, what happens here? If sigma n ranges from 1 to infinity, or sigma with respect to n, cos n converges. Then by nth term test, what is limit cos n? Then limit cos n equals 0. Okay, limit cos n equals 0. Now consider for a subsequence, let nk. Let nk equals to k pi, where k is any integer. Clearly cos nk being a subsequence of cosine. Sure? Cos nk being a subsequence of cosine. Okay. So, what about limit n tends to infinity cos nk? Limit n tends to infinity cos nk means it is limit n tends to infinity cos what is nk? 2k pi. So, limit n tends to infinity 2k pi is always 1. Enough? Consider another subsequence. Nk equals pi by 2 plus k pi. Consider another sequence. Nk dash equals pi by 2 plus k dash pi, where k dash following such. So, what about clearly here cos nk dash is a subsequence of cos nk. Sorry, cos nk dash is a subsequence of cos. Clear? Now limit limit n tends to infinity cos nk dash equals limit n tends to infinity pi by 2 plus k dash pi. Okay? Limit n tends to infinity cos limit n tends to infinity cos pi by 2 plus k dash pi. So what I get? Its limiting value is 0 itself. Means cos nk dash be a subsequence of cosine. Cos nk is also a subsequence of cosine. But these two subsequences are converges to different limits. If sigma n ranges from 1 to infinity cosine converges, then we reach this complex. That is, two of the subsequences cos n converges to different limits. That means sigma n ranges from 1 to infinity cosine always diverges. Okay. So that's an important result. Sigma n ranges from 1 to infinity cosine always diverges. Enough. Okay. What about sigma 1 to infinity cos n by n square? Sigma n. So, what about cos n by n square? We have cos n by n square less than or equals 1 by n square. Sure. Why? Because the maximum value or maximum and the minimum value of cos n is plus 1 and minus 1. So, modulus of cos n by n square less than or equals 1 by n square. That means cos n by n square less than or equals 1 by n square. So, means sigma cos n by n square less than or equals sigma 1 by n square. What is sigma 1 by n square? Sigma 1 by n square is converges. Okay. So, by comparison test, sigma cos n by n square is also converges. Clear? Now come to another result. Suppose sequence A be a sequence of positive reals. Then consider sigma a n with a n greater than 0, not greater than or equals 0, greater than 0. Then sigma a n converges. Sigma a n converges where a n be the sequence of positive reals. What about sigma a n square? Is it converges? Sigma a n where a n be the sequence of positive reals is converges. Then check whether sigma a n square converges or not. So for listen, what is sigma a n? Sigma a n converges. Agree. Sigma a n converges implies limit a n equals 0. Why? Limit a n equals 0 because of nth term test. Clear? Limit a n equals sigma a n converges means limit a n equals 0 by nth term test. Enough? Limit a n equals 0 means for all epsilon positive, there exists k following n such that modulus of a n minus 0 strictly less than epsilon for all n greater than or equals k. Agreed? That means modulus of an strictly less than epsilon for all n greater than or equals k. Put epsilon equals 1. What I get? Modulus of an strictly less than 1. Mod an strictly less than 1 means an strictly less than 1 for all n greater than or equals k, because an is greater than 0. Positive bits. So an less than 1. Since an is positive, so it is 0 less than an less than 1. Clear? That means 0 less than an square less than an. Okay. But what is an less than 1. So 0 less than an square less than 0 less than an square less than 1 means multiplying throughout by an, 0 less than an square less than an. So that means 0 less than an square less than an less than 1. Why? Because an less than 1. So an square less than an means sigma an square less than sigma an. What is sigma an? Converges. So sigma an converges. So by comparison test, sigma an square also converges. Agreed? But when sigma an converges with an greater than 0, so what about the sigma root a? When sigma an converges with an greater than 0, then sigma an square converges. When sigma an converges with an greater than 0, what about the sigma root an? Is it converges or diverges? That's an important result. So, see, sigma an converges, then limit an equals 0. But put for an example, put an equals 1 by n square. Clearly we know that sigma an equals sigma 1 by n square, so it converges. Agreed? What is sigma root an? Sigma root an equals sigma root 1 by n square. Sigma root 1 by n square means sigma 1 by n. Okay. What is sigma 1 by n? We know that sigma 1 by n diverges. So when sigma an converges, it for an greater than 0, it need not implies sigma root an converges. Clear? Yes. Now, if sigma an with an greater than 0 is converges, then if Bn equals, define another sequence, Bn, if Bn equals a1 plus etc. plus an divided by n, for n fallen in, then sigma Bn always diverge. Sigma Bn diverge. How to prove this one? It's an interesting result. When sigma an with an greater than 0 is convergent, and let Bn is a1 plus etc. plus an by n, then sigma Bn always diverges. How? So, that's an important result. Consider Sn, the nth partial sum of the given series. What is Sn here? Nth partial sum of the given series means Sn equals a1 plus etc. plus a. Okay. What is a? Clearly an greater than 0. Then what is secant Sn? Secant Sn is monotonically increasing. Okay. Since the Sn equals a1 plus etc. plus an and an greater than 0, then secant Sn is monotonically increasing. Secant Sn is a monotonically increasing sequence means Sn greater than S1. Clear? What is actually S1? S1 means A1. Okay. Now, from Bn, what is Bn? Bn equals A1 plus A2 plus etc. plus an all divided by a. Okay? Yes. What is S1 here? So clear, from Bn we have S1 strictly less than Sn for all n. Let Sn be the nth partial sum of this Bn. What happens? What is S1? A1. What is S2? A1 plus A2 by 2. What is Sn? A1 plus A2 plus An etc. by n. So surely when An increases, S1 plus Sn. S1 strictly less than Sn for all n. Clear? From Bn. That is from Bn. That means S1 by n strictly less than Sn by n. Okay. Yes. That means what is S1? S1 is A1. So it is A1 by n strictly less than Sn by n. What is Sn by n? Sn means A1 plus A2 plus etc. plus An. So Sn by n is Bn. So A1 by n strictly less than Bn. But what is sigma 1 by n? Sigma 1 by n, we know that sigma 1 by n is, for going to that one, A1 by n strictly less than Bn means sigma A1 by n strictly less than sigma b. Okay, with respect to n. So, but sigma 1 by n diverges, that means sigma A1 by n also diverges. Sure? By comparison test, what you get? Clearly sigma Bn diverges. Clear? Okay. So, let's say crucial. Sigma An converges with An greater than 0, but average Bn equals A1 plus etc. plus An by n always diverges. Agreed? Okay. So this is the end of this chapter. Now let us consider the next chapter, that is absolute convergence. What is that? Is chapter 9, absolute convergence. Absolute convergence means convergence and convergence, absolute convergence and non-absolute convergence. Non-absolute convergence is also known as conditionally convergence. So, consider let x equals xn be a sequence of real numbers. Then the secant xn is said to be absolutely convergent if the series sigma mod xn converges. That is absolute convergence. The series sigma xn said to be, then sigma xn said to be absolutely convergent if sigma mod xn converges. Let x equals xn be a sequence of real numbers, then the series sigma xn said to be absolutely converges only when sigma mod xn converges. Agreed? A series is said to be non-absolute convergence. The non-absolute convergence is also known as conditional convergence. So a series is conditionally convergent or non-absolutely convergent if it is convergent but not absolutely. Clear? Sequence a series sigma xn is said to be absolutely convergent if sigma mod xn converges. A series sigma xn is said to be non-absolutely or conditionally convergent if it is convergent but not absolutely convergent. Clear? So, consider alternating harmonic series. What is alternating harmonic series? Sigma minus 1 power n plus 1 by n. Okay? Sigma minus 1 power n plus 1 by n. What is sigma 1 by n? We know that sigma 1 by n diverges, but the alternating harmonic series, sigma 1 by n is the harmonic series. So, alternating harmonic series, we see that sigma minus 1 power n plus 1 by n converges. But what about sigma modulus of minus 1 power n plus 1 by n? That equals sigma 1 by n. It diverges. Clear? So sigma minus 1 power n plus 1 by n is converges, but its modulus is diverges. That means the alternating harmonic series sigma minus 1 power n plus 1 by n is conditionally converges, that is, it converges but not absolutely. So, the alternating harmonic series is conditionally convergent, means it is not absolutely convergent. Clear? Okay. So, what about the relation between this convergency and the absolute convergency? A series is converges, is it implies absolute converges or vice versa? Clearly, we say that absolute Absolute convergence always implies convergence. What about the reverse inclusion? Reverse inclusion need not be true. Absolute convergence always implies convergence. Why? For let sigma xn is absolutely convergent. Consider a series x equals xn be a series of real numbers such that sigma xn converges absolutely. Sigma xn absolutely convergent means sigma mod xn converges. Okay? Sigma mod xn converges. So by Cauchy's criterion, for all epsilon positive, there exists some k following n such that modulus of xn plus 1 plus etc plus xm strictly less than epsilon. Why? Because let San equals Sn and Sm be the any two partial sums with m greater than n, then by Cauchy criterion Sm minus Sn strictly less than epsilon. That means modulus of xn plus 1 plus etc plus xm strictly less than epsilon. Since it is modulus, so we have modulus of each of this modulus. That is, for more convenience, it is modulus of each of its modulus. Modulus of xn plus 1 plus modulus of xn plus 2 plus etc plus modulus of mod xm strictly less than epsilon. Clear? For all n, m greater than or equals this particular stage k following n. So modulus of this one should less than epsilon means modulus of xn plus 1 plus etc plus modulus of xm strictly less than epsilon. Agreed? For all n, m greater than or equals k. But what about modulus of xn plus 1 plus etc plus xm? That is less than or equals modulus of xm plus 1 plus modulus of xn plus 2 plus etc plus modulus of xm. So it is strictly less than epsilon. Okay. Yes. Modulus of xn plus 1 plus etc plus xm strictly less than epsilon. That means that is true for every n, m greater than or equals k. Then by Cauchy's criterion, sigma xn converges. Clear? Sigma xn is absolutely convergent, means sigma mod xn converges. So by Cauchy criterion, for all epsilon is positive, modulus of xn plus 1, modulus of xn plus 2, etc., modulus of xm strictly less than epsilon. Okay, by Cauchy criterion. But modulus of this one strictly less than, that is modulus of xn plus 1 plus xm strictly less than epsilon. But using this inequality, we have